Alright, welcome everybody to the 2022 Whidbey Island WIldcats Design Competition and our design night. I am Mr. Doga.
I'm Isaac Schultz.
So I'm one of the mentors for the team, and Isaac is the oldest member of the team.
Yep.
So Isaac's been around on the team the longest, and so Isaac is here to help us out with this. Alright, so first of all, I'd like to just welcome everybody. Normally we have a completely different, normally this event has a completely different feel, and that's because normally we do this in front of an audience. But unfortunately, because of COVID and some other things, we're trying to keep it safe, and so we're doing it virtually, and hopefully you guys are all able to join us from home. So thank you guys very much, and we're glad to be able to do it, and we're glad that we're able to compete in person this year. It's going to be awesome. So the way in which this normally works is we start out with some introductory stuff. We'll talk about the school a little bit. We'll talk about the team a little bit. And then we're going to have each of our three groups. We have three different design teams, and they're going to come up and present their idea for how to play this year's FRC game. After that, we've got some Google Forms that there will be links to in the presentation, and you guys can follow those links and you can vote. And then we're going to look at the votes, and then we're going to go from there. And sponsors. Okay, so the school district asked us to share a video. It's actually about the school,
librarians, and much more.
Yeah, but a bond is different. To help me remember the difference, I like to say bonds are for building and levies are for learning. One more difference is that bonds require supermajority, or 60% to be approved.
The last time we voted on a bond was in 2006. I wasn't even born then. Those bonds built Oak Harbor High School and Wildcat Memorial Stadium, which were completed on time and on budget.
The best part is those bonds will be paid off this year, making this a replacement bond and not a new tax.
Currently, our elementary schools are overcrowded. We have 40 portable classrooms in the district because our aging schools are too small.
Oak Harbor Elementary was built in 1934 when FDR was president. That's really old.
Schools have changed since then. New schools have larger classrooms, gymnasiums that don't double as cafeterias, better playgrounds, modern safety and security systems, updated technology, better HVAC systems, and are built for today's learning.
Woohoo! Building schools can be expensive, which is why Oak Harbor Public Schools worked hard to pay for their portion of the project. Thanks to the Department of Defense, like the Navy and the state, they're going to pay for 43% of this bond project.
Wow! However, this funding is only available if voters approve the measure, but we have good news for taxpayers. The estimated tax rate will be $1.89 per $1,000 of assessed property value, which is 4 cents cheaper than the bond rate in 2015.
We have some of the best teachers in the state. Imagine what great teachers can do in great spaces.
Well, that's all we have for you. Only thing left to do is turn in your ballot by February 8th.
This message is read by students from Oak Harbor Public Schools.
Alright, so thank you to the school district for supplying us with that video. Now, Isaac, we are doing something pretty new this year for us and our team, and we are going to be giving out a service challenge. And so we do a lot of service, like you guys do a lot of community service. And so what we're doing is we're challenging our school district, so that is classes, clubs, or just groups of people who want to go out and do a service project. We're challenging you guys, and if you guys submit your service projects, then the Robotics Club is going to support you guys. If you're a school, an elementary school, we're going to throw a pizza party for you. And if you are a club at the high school, then it looks like we're getting some new equipment for you.
Yep.
You guys recorded a video about that yesterday?
Yes, we did.
Awesome. So let's go ahead and play the video that you guys recorded yesterday.
Here at the Robotics Club, we don't just build robots, we build people.
I mean, our robots are really cool.
but we also use the things we learned from our robots to give back and improve our community.
Some of the things we do are big. We built and repaired animatronic deer used to catch poachers.
We used 3D printers to make prosthetics for children with disabilities.
We designed and made haptic devices that use range-finding sensors to help sight-impaired people improve their sense of direction.
And we designed and built 2 self-contained microhomes that are donated to provide housing for the less fortunate.
But some of our projects are smaller.
We help build and install wheelchair ramps for community members who need help getting into and out of their homes.
We organize blanket drives to collect warm covers for people in the cold.
We work with schools to build sheds for their teaching gardens.
Our work in the community is why we say it's not about the robot. Now it's your turn.
We are challenging the classes, clubs, and groups of students in our district to make a difference in our community.
Starting today, form a group and pick a community service project.
It doesn't have to be big. Everything that helps makes our community better.
Submit your project to let us know what you're doing. And we'll give prizes for the best projects. Submit your project by February 18th, and we'll announce the winners at our Robot Reveal Night on March 1st.
The best project by an elementary or intermediate school group wins a pizza party.
We will buy some new equipment for the middle or high school group with the best project.
Check out our webpage for more details.
Alright, so again, go out and do service for the community and hopefully win a prize for doing it. That makes me really happy that we get to do that this year. So with me now, I have Jonathan Shields. He's a member of our team. He's an awesome guy. And Jonathan, you told me something pretty incredible about how you got to be a member of our team. And you said that your story with our team actually started back in 7th grade.
Yes.
But you didn't join until last year. So why don't you tell us a little bit about, kind of your history with the team and how you got to be here.
So in 7th grade, I first learned of the team, and I was told that I could not do it until my 8th grade year in middle school. So, as pursuing that, asking to join the robotics team in 8th grade, I was told by one of the teachers at the middle school that I was unable to do robotics because of basically me being in life skills and having an IEP. And I believed that for 2 years in my 9th grade year in high school and my sophomore year. Finally, in my junior year, I got sick and tired of being told that I can't do anything, and faced my biggest challenge of my life, which was joining the robotics team.
I'm so glad that you did that, and I'm so sorry that someone told you that. Like, that someone told you that you couldn't be a part of our team. Because you know now that that's not true, right?
Yes.
And I would hate for anybody out there to think that they couldn't be a member of our team for any reason, right?
Right.
And so I'm so glad that you're here. So you and I, we have an event coming up, and we have a meeting about scheduling that event, right?
Yes.
And do you want to tell everybody a little bit about that event and what that event is?
Yes. We are scheduling an event for Unified Robotics. And Unified Robotics is basically to schedule a day where we have a day with our life skill community building robots and having a day dedicated for doing that.
Yeah, no, that's so awesome that you are a member of our team and that you are you're actually leading that event.
Yes, I am.
And that's amazing. That whoever it is that told you that you couldn't be in robotics, well, that person, I hope they're watching now, because look at you now, you're leading an event dedicated to life skills students.
Yep.
And that's one of the most wonderful things I can think of at all. All right?
Thank you.
So, John, I just learned something, and we are nominating you for a scholarship as being a champion in diversity. You gonna have a high five? All right. Thank you, John. Thank you very much, and thank you for sharing with the community.
You're welcome.
All right.
Anytime.
All right, get out of here. All right, so I do want to take a minute to thank or to memorialize a great man named Woody Flowers. And last year, I was really honored to be nominated for the Woody Flowers Award, and that's an award for mentors. And it means a lot, and it means a lot to me, and so I want to thank the team for nominating me. And I was recognized by our local district as a Woody Flowers finalist. And so thank you to the team, and thank you to everybody else for nominating me and for the support. And I got to meet Woody Flowers once, and he's a pretty incredible guy. And the idea of gracious professionalism is something that I try to incorporate in all my classes, and we try to incorporate on our team. And so thank you, and I hope thank you to him for his contributions. So every year we kind of have a theme, and this year's theme or idea or concept or underlying structure is to make it so. And I generally come up with these ideas when I'm in the shower, and it's basically this. I want the team to create the world that they want to see. And we're going to do that through sheer force of will. We're just going to go out into the world and mold it into the shape that we want it to be in. And so one of the things we're doing is we are working to change our community. We're working to promote the idea of service and the idea of getting out to the community and doing good things. And we are going to keep pushing until those changes happen. All right, so I hope you guys can join us, and we are going to make it so. So this year's game is called Rapid React, and here I'm going to play the game animation video that will tell you guys about the game for this year.
Presented by the Boeing Company. Two alliances of 3 teams each compete to score their cargo balls into the lower hub and the upper hub. They earn additional points if the robots traverse the rungs of their hangar. Robots start each match on one of their tarmacs and may be preloaded with 1 cargo each. During the first 15 seconds, robots are autonomous. Without guidance from drivers, they leave their tarmac, score preloaded cargo, and collect and score additional cargo. During the remaining 2 minutes and 15 seconds, drivers control their robots. They continue to gather up 2 cargo at a time and score cargo in the lower and upper hubs. Cargo scored into either hub count towards the cargo bonus. Launch pads protect robots from contact by opponent robots. Robots may use either terminal, where their human players assist the robots with acquiring cargo. As time runs out, robots race to their hangar and traverse as many rungs as possible. The higher a robot gets, the more points it earns. An alliance that reaches a hangar point threshold is rewarded with a ranking point. The alliance that earns the most points wins the match.
All right, so here I am with Jack. Jack's one of the members of our team. So Jack, what do you think about this year's game?
I think it's exciting. It brings a lot of cool game elements to the table and gave us a lot of interesting challenges with designing, especially with the climbing.
All right, so do you think we're going to see a lot of robots climbing past that mid-level?
I think it's a really hard challenge, but I think it's one that a lot of teams are going to shoot for.
Cool. All right. And then, what do you think about the hub? So you've got to get the cargo. Those are the balls. You've got to get those into the hub. And what are your thoughts on that? You think there's going to be a lot of high goal, or you think it's going to be all low goal? What are your thoughts?
I think it's going to be mostly high goal, with a very few exceptions of teams that can do it really fast and low goal.
Okay. All right. Cool. Thank you. All right. Thanks, Jeff. So, let me see.
Welcome to the...
Alright, so, Isaac's going to come back, and Isaac's going to talk about Swerve Drive. And so our teams, all of our design teams chose to work with a new drivetrain this year. And so we're looking at Swerve Drive, which is a new type of drivetrain.
So, unlike some of the other drivetrains that we've used in the past, such as Mecanum or Tank Drive, where you rotate the robot and you can drive straight and stuff, and in the case of Mecanum, you can strafe, but you can't like turn and strafe at the same time. Swerve Drive is super maneuverable because all four wheels, there's wheels in each of the corner, and all of them can turn in individual directions, allowing you to be able to go in a specific direction and rotate while you're moving and a pretty high rate of speed. And there's like no pushback because your wheels are actually pointing in the direction that you want to go, whereas in Mecanum, when you're strafing, your wheels aren't actually pointing in that direction. So some of the pros and cons, like I've already mentioned, it's highly maneuverable, extremely fast, and you're not going to be pushed around much on the field. We already have a working, mostly working Swerve Drive set up in the classroom right now, but the only issue is that we've never actually used Swerve Drive in an actual competition, so we're kind of new to how it works. We haven't done extensive repairs on it when it's fallen off of a climb or anything like that, but we'll work on that.
Yeah, and you've gotten it working.
Yes,
yeah.
we've
right?
gotten
so
it
you guys have gotten the initial thing working, and obviously for competition we need to take it all apart and put it back together again.
Yep.
And that's good because that means everyone will kind of learn how to do that. Yeah. But you've never used it in competition before.
Yes. And
realistically, as a team, we don't have any experience with it outside of getting it working during the off season.
Yes.
Yeah. Okay.
And the program is also much more complicated than a standard drivetrain. A standard drivetrain, you have your left and your right, and they kind of operate independently of each other. Whereas with this one, you have 4 wheels, two motors per wheel, and you have to program it so that the wheels are all facing the correct direction as it's moving. It's a little bit more complicated, but I think we can do it.
Awesome. And you guys consulted with some of the math teachers, right, to understand the underlying math behind that?
A few of them.
Yeah.
Just a few.
Just a few. just the whole math department.
Yeah.
All right. So there are some cons to using Swerve Drive.
But it is extremely maneuverable.
It is extremely maneuverable. Wait.
Oh, not yet.
What are the cons? So we've never used it before. Yeah. It's complicated to program. And there's another con there. There's two more cons there.
Well, there's not a lot of replacement parts.
So
mainly because we have version 2, but they have version 4i.
So it's kind of like an iPhone, and there's the latest and greatest, and we have like an iPhone 5.
Basically.
So we have the old iPhone, and they're on the latest version. So we can't get replacement parts. There is a conversion kit that you can buy, so we can convert to the latest version. But that's also a lot of extra time that we may not have for this season.
And it's also almost as much as a brand new module.
That is true. And so then the other idea is to basically get
the parts we can get.
Get the parts we can get, and get some of the parts made for us using like one of the 3D printing houses that we have access to through FIRST. All right, so you want to go ahead, now we're going to show the video?
Yep.
All right, so now there is a video that we will share with you of another team kind of demonstrating Swerve.
Is from last year, another team that used Swerve Drive and how maneuverable they were able to be on a large field.
That one.
This is
Robo Wranglers.
Yeah.
No, but is it speed up?
No, this is real-time speed.
Yeah. So this is how fast it can go real time, basically.
This is also one of the best teams in the country.
Well, yeah, that too. They've done some tuning, let's just say that.
It's a great way of showing some of the capabilities of Swerve Drive.
That is pretty incredible. So that's a top view of the robot.
Yep. I think they might have had a not top view.
Alright, so that just kind of, you can see the Swerve modules inside of there. Now that's a different version than our version, right?
Yeah, I believe they have the 4i.
Yeah, that does kind of look like the 4i there.
That actually looks like they just made their own custom.
Yeah.
Anyway.
Alright, well, thank you, Isaac, for sharing that with us. And, let's see. So next up, we have our sub-teams presenting. And the first one is going to be Pogbot.
Alright.
And I believe that is...
My team, so let me go get them.
So Jack's going to go get his team, and they're going to present... No, not mine. They're going to present their robot design, Pogbot.
Okay. Well, let's let everyone get in frame room. Can you see everyone? Okay. Here. So our robot's name is Pogbot. It's an acronym. What did we decide the acronym was? Okay. Yeah, it's an acronym. Our goals. We're gonna have Branson tell us tell us about that.
So the main goals of our robot design will be to have the max efficiency that we can. Just to go as fast as we can, super low cycle times, and just get tons and tons of balls scored into the hub so that we can get our 20 ball cargo bonus, which we will talk about a little bit later. Now for our strategy. So, when the game starts, the first 15 seconds are called the autonomous period, where the robot has to control itself. And there are several different ways you can score, and we plan on doing as much of them as we can. The first way to score is your robot can come with the ball preloaded inside of its Outtake, and we will try to put our ball into the lower section of the hub to get some bonus points for that. Another way to score is to back outside of the taped off tarmac area, and we get an extra 1 point for that. After that, we will attempt to grab another ball, or as many as we can, and then bring it back and put as many as we can in during autonomous. We will see how many that will be later on. We don't really know at this point how many we can get.
We're shooting for 9 total cycles of 2 balls in
Tele-Op, which is up next right here. The Tele-Operated Period. This is when the drivers of the robot actually drive, as opposed to the robot driving itself. We will be taking advantage of the bottom hub as opposed to the top, so we can score 2 balls at once. Some specific reasons for this would be because it is faster, more reliable, and we don't need any time to aim. So our reasoning is, on the top hub, you get 2 points. On the bottom, you get 1. So it sounds like the top hub is like the big place to be. Like, that's where you want to go. But there is a big but. We will be so much faster on the bottom that I think we will be able to get almost as many, if not more points that way, because we don't have to line ourselves up to aim. We don't have to wait for the balls to shoot. All we have to do is roll up to the side of the hub and dump them in. Just like that. 2 balls. Instant score. One of the big reasons for this is because if we get 20 balls scored, whole alliance, 20 balls scored across the entirety of the game, we get an additional ranking point, which is very important because ranking points are what decide where you rank in the match. If you win, you get 2 of them. So even if we lose and get 20 balls, we still get a ranking point, which sounds pretty stinking good to me. At the end of the Tele-Op period, we will attempt to do a climb onto the hangar area. Now, we have thought again of time and efficiency and different aspects that come in. So we've decided to only shoot for the second bar for 6 points because a climber mechanism to get any higher would take up too much space, it'd be hard to maintain, it'd get in the way of other things, and getting to the second bar would be much easier for not that big of a loss of points. One that could probably be almost made up by the time we would save not climbing. Let's see who's next.
Our drivetrain, like me, Isaac, and Mr. Yoga mentioned, our drivetrain is Swerve. Our Swerve will be 28 by 28 inches, 8 inches below the minimum per. One other big downside of Swerve is it takes up 8 motors, half of our allowed motors. There's extreme mobility. Swerve can move in almost any direction, and in the video before, you guys saw how fast Swerve can move. Our intake.
So our intake system is a mechanism that allows the robot to acquire and store game objects. It consists of multiple wheels placed through a metal rod, and these wheels will rotate inwards to take in the rod, or take in the ball. And our intake system is designed for speed, so as soon as the robot goes over a ball, it immediately takes it in. Once an alliance ball is sucked into our robot, it moves up through a conveyor belt that carries it to our outtake system.
Another example for, well, I guess, yeah, this one has a lot to talk about. So another example for part of our intake is we will have a bar of macadam wheels on the front of it. That way it takes the balls towards the center where it needs to be to intake them. Outtake. Okay.
The outtake consists of a bucket that's about 3.5 feet above the ground, which is how high the bottom shipping hub rim is from the ground. When the conveyor belt intakes the balls, it drops them into the bucket, which then flips over a little past 180 degrees into the bottom shipping hub, once we're close enough to it.
Here are some of our drawings and CAD models that we've made of the bucket so far. You can see in the little drawing in the corner, which actually I drew myself. I'm very proud of it. It's pretty cool looking. So, you know, you can see our intake with our green wheels going up the conveyor belt into the bucket in the back, which, as you can see in this little image here, has actually flipped over, and you can see one of our red balls falling into the lower portion of the hub. This is a pretty general idea of what it's going to be doing, and we hope that this will be just as fast as anybody else.
Our climbing.
Our plans.
Our plans to have our robot climb to the second bar in the hangar area. Is a set of linear slides with hooks attached to the end.
So it's just very similar to the design that we've used in previous years, with a linear slide that will go up, a hook on the end, which we can attach to the second level bar, and pull our robot up to get our 6 points.
This year it's slightly different. Instead of using a winch, we're just going to hang on the 2 bars mounted on each side of the robot. Thank you guys. Got any questions?
So we're going to do a question session afterwards.
Okay, we'll come back to this.
Awesome. Thank you guys. Thank you for your presentation. Why don't you guys send in the next team? Send in the next victim.
What am I getting?
Who are the next people?
I don't know who they are.
They're right in the hallway.
Okay.
Alright, so in case you were wondering, this is an example of the cargo. So it is a large tennis ball. It's pretty lightweight, and they're not round. They're not perfectly round. Alright, so next up we have Mayonnaise and Connor's group with their robot Mayonnaise.
This is our robot called Mayonnaise, and I'm Danny.
I'm Connor.
I'm Jonathan.
I'm Aiden.
Let's get started. So our autonomous period plan was to first score a preloaded ball that was in the robot before and get it into the hub. And then once we do that, we were going to taxi away from the tarmac, which is the blue and red zones located in the next to the hub for the points. And then once we've scored and taxied, we were going to then pick up a ball to be ready for Tele-Op, so we have something there and ready to score once we end the autonomous period. Next, our Tele-Op period is the bulk of the match, and this is where we're going to want to be scoring most of our points. And so our focus in this match is to have as many balls scored into the lower hub as possible. This would make for a good cycle time to be our best option. And so we want to move fast and pick up balls quickly to maximize the points we score.
Towards the last 30 seconds of the game is end game. Our plan is to shoot as our last few balls into the lower hub and rush to the lower pole.
We chose to use the Swerve Drive to maximize the amount of speed we can use in our robot, given the route we're taking for scoring points.
Our intake-outtake system, which is going to be the most important part of our robot, we thought of using a conveyor belt with Velcro because we know Velcro sticks very well to tennis balls. So our idea was that we would roll up to the tennis ball, move the conveyor belt, and pick it up, and then dump it off right at over top of the lower hub. And then we have a 2 conveyor belt design, which would allow us to carry the maximum 2 balls at a time and not have to cycle through a ball and then have to pick it up again. And instead we would just be able to have 2 and drop both of them off, allowing for a faster and more efficient cycle time. That is the end of our presentation.
Alright, guys, thank you. Okay, so next up we have Isaac's group and their robot Factor. Actually, I don't know if the robot's name is your robot's name Factor or Factor Design?
The group name can be Factor Design, the robot's Factor.
Alright, so here's Isaac's group with their robot Factor.
Hi, I'm Isaac.
Hi, I'm Airstein.
Hi, I'm Indiana.
Hi, I'm Jacob.
Hi, I'm Jonathan. This drawing, this Cad model is basically a model in the block form, which is on the right. On the left is a drawing of what the robot is going to be once it is assembled.
So basically the CAD model just goes to show where things would be placed in the robot, and the drawing shows like the physical images.
Our drivetrain we chose was a Swerve Drive. The Swerve Drive has 4 wheels and 2 motors per gearbox, which is 8 motors. The Swerve Drive has more maneuverability than the regular chassis, which is lightweight. Our Swerve Drive has a gap at the front for the intake. The problem with the Swerve Drive is that it's more difficult to build and program. Our team has no prior experience, and there is minimal access to spare parts.
So for our intake, we would have multiple wheels on a bar, and it would flip down and extend out a little bit. When we run over a cargo, the wheels would spin, and it would intake the cargo into the robot. The pros are, it is reliable, and we have used this type before. Another pro is that it should be quick, depending on what motor we have, because some are faster than others. Cons are that it sticks out of the frame.
Okay, so here is our launcher. The bottom image is like a basic CAD model, and the top is a drawing showing how the ball would travel through the launcher. Basically, the ball would get sucked into the intake and then put onto a conveyor belt. The conveyor belt would then bring the ball up towards a piston, which would then hit the ball in between two spinning wheels. The pros is that you're able to launch balls with much like consistency. You do not need to adjust the position of the launcher every time you shoot. Also, the cons is that the piston could lock up, and you could also piston could lock up. You also can't adjust like where the tower is aimed, and the basically the launcher could be in the way of the hanger bars.
Now onto the climber. Our idea for the climber is going to be basically the same as what we used last year and the year before. We'll have a linear slide system where it will slide up on one side and put the hook onto the bar. And then on the other side of the robot will be a winch feeding a rope through a pulley in the center of the robot, which will allow the robot to lift itself up using the winch. The pros to this is that we've used it before and we know how to fix it if it breaks, and it's fairly reliable. The biggest issue with it has to be that it's a hassle to reset after a match, because then you have to stuff the rope back into somewhere in the robot so that it's not like laying around. And for our game plan, we'll leave the starting area, score a few points for that, and then we'll try to score 2 cargo in the upper area. We'll score the cargo that's in the robot, and then we'll try to use a vision system to grab another piece of cargo and score a second piece in the top goal. And then for Tele-Op, we're hoping to score at least 8 cargo in the lower goal. And then, of course, for the end game, we would be using our hanging mechanism climber to climb up and hang for end game on the middle run. Yep. Thank you.
Alright, awesome job, you guys. Thank you. Isaac, I'd love for you to stick around for a bit, and everybody else, why don't you guys all head out, head back to the classroom. Alright? Okay, so, here's what we are going to do. So, we are going to have one representative from each team. They're going to come, one representative from each group is going to come in here, and Isaac is going to be live reading the comments, and we would love for you guys to give us some feedback on what you'd like to see us do. Alright, so Isaac, I'm going to go get one representative from each team. Why don't you tell them your story of how you got to be on the team and what you're looking forward to most this year.
Okay. So, I originally learned about the robotics team in 7th grade, kind of like John. And then from there, I joined the FLL team at North Whidbey Middle School. After that, I wanted to be able to participate at the high school level, so I joined the FTC robotics team and competed in that year, and then when we got to FRC season, I helped out with some of the special projects and community projects. And then, once I got to high school, I joined the FRC team, and I've slowly been taking on more and more as we've gone on. What I hope to accomplish this year is passing on knowledge to all the current teammates, so that way when I graduate this year, they'll know what to do and won't be like, what's going on?
Thank you, Isaac. Alright, so we're going to have one person from each design team come up. And Isaac, if you could, read the comments. And then basically you guys are here to answer any questions that people have about your various designs.
So that team has a launcher that is only used for the high goal and the autonomous period?
Mm-hmm.
So does it only work for the high goal?
So we're planning for it to go for the high goal so we can score more points, but if need be, we can also let it go for the low goal during autonomous.
I think the plan with the launcher is also that we can change the speed of the wheels to change the trajectory of the ball. If we're going for the low goal, we'll just like stop the bottom wheel and have it kind of spit it out into the low goal. How does the piston interact with the launcher?
Oh, so the plan for the piston is that basically the conveyor belt would only bring the ball so far. That way we can get the wheels to be spinning before the ball makes contact, and then the piston would go and just like push the ball close enough to the wheel so it would then get launched.
On the second robot, how will the balls come off of the Velcro on the conveyor belt?
Okay, so the Velcro is really sticky and we planted that, so we're gonna have like a scraper thing that's gonna like peel the Velcro off the ball, and it'll just roll off the, Velcro into the hub.
Any other questions?
Maybe let's scroll up a little back.
Does traverse mean they can't go straight for the top rung?
Yes. You can't extend high enough to go straight for the top rung.
You can only extend 16 inches past.
Yes.
For example, must they start at the lowest one and work their way up?
It's a little more than 16 inches for up.
Oh.
But
how did you come up with the Velcro?
It was just an idea we had thought about. We were debating between an intake that's had 2 spinning wheels or a Velcro conveyor belt, and we decided on the Velcro conveyor belt just because it felt like a more fun idea to build and just an overall better robot.
Is the new Swerve Drive too expensive for the budget or not available?
the new Swerve Drive, the issue with that is, yes, it's a little expensive, but it's not too expensive for our current budget. We're probably just either going to end up totally upgrading, maybe partially upgrading, or just buying the spare parts that we need to do what we need to do with our current Swerve Drive modules.
There's also a little bit of a delay in the Swerve Drive modules. Let's see, is buddy climbing a thing from a rules perspective?
Like, so climbing on another robot?
Yeah.
No, that's not allowed. Yeah. A robot can't be fully supported by, like, another robot, I think is what the rule says.
For all designs, when hooking onto the endgame bar, how do you plan to monkey bar from each of the bars, and how far up are you trying to go?
Can I go first on that one? So if you're getting to the mid bar, which is the second lowest bar, you do not need to actually monkey climb. Instead, there's a black line of tape on the ground that you can align your robot with, so you can just go straight up and latch on. And that's what we're planning on doing.
That's also what we're planning on doing.
Personally, our robot was just going to wedge onto the first rung and not even attempt to climb.
In theory, how heavy do you think each robot will be?
They're probably going to be decently close to the weight limit.
Can we get an estimate on that?
About probably somewhere in the neighborhood of 100 to 120 pounds.
The weight limit this year is 125. Is there a ranking point to be gained from enough climbing points?
Yes.
Between the alliance.
Between the alliance, if you get 16 points, I believe it's either 1 or 2 ranking points.
I think it's
1 ranking point.
Yeah,
it's 1 ranking point.
You can get 4 total.
Yeah. Logan says, so all teams on the second bar?
That would work. Yeah.
That would theoretically work, yeah.
Yeah.
Natalie says, Swiss cheese.
Swiss?
Nice.
Which,
yeah, hopefully we don't have to Swiss cheese our robot this year. We're hoping that our robot is light enough that we don't need to Swiss cheese it.
Hopefully.
But then again, sometimes it looks cool, so we'll see.
Speed holes is what we see. No wheels.
No Swiss
Yes.
cheese.
Yes, wheels is what I meant to say.
Any other questions about the robot design? For all robots, how many total motors are your designs, including the 8 Swerve Drive motors?
Mayonnaise's total motors is 12.
13 for Pogbot.
I could be wrong, but I think it's around like 11 or 12 motors for factory.
That's with Swerve Drive for all of them. I'm assuming.
So you got 8 motors for Swerve
Yeah,
Drive.
I'd say 12 motors for our
Including
robot.
Swerve Drive.
Let's see. Could you point to where the battery will go in each robot?
We have the present.
Yeah, the presentations are right here. Let's see. Let's see. That's Swerve Drive.
Presentation
Factory design. Here.
Okay.
I'll let you guys go
So
first.
we had planned on putting a little compartment beneath the conveyor belt because the conveyor belt's going to be spanning up at an angle of the robot. So underneath we were going to put like in a little electronics department like right here-ish. So you can put your batteries and any like wires and stuff to kind of hide them away in a specific pocket and help keep them organized.
Sure. Okay. Let me find the drivetrain because that's where it would be. Okay. So all of our electronics would be towards the back of the robot. That way we can maintain our easily maintainable, so we can quickly switch batteries and maintain the electronics.
And then for our design, it would go back here, basically. We have pretty much like a section in the back for electronics.
Alright. What motor is the launcher using? Is that... I'm assuming that's for all...
We don't have launchers.
Okay, so for ours. Probably Neos is what I'd say. Rev Neos.
Neos or Neo 550s.
Yeah.
Regular Neos.
Not the 550s.
Yeah, regular Neos in that case.
Let's see.
But the closest thing to a launcher on our robot is our intake, and it's using Neo 550s.
For the team with the actuated dumper, how do you guys plan to actuate it?
We are going to actuate it using pneumatic cylinders.
Alright. How much RGB do you intend to decorate the robot with?
Is that from Wheels?
No, that's from Mason.
No, that's Kelly asking Mason.
No, that's from Mason.
Oh, yeah. Oh, yes. RGB? Probably not. There will be Mr. Blanky, but besides Mr. Blanky, there will be no RGB.
It's disappointing.
Except for unless we have abundance of extra power, and I decide I want to go RGB crazy.
Do you guys know if we can practice with Anacortes this year?
I do not know. Adoga, do you have any objections with that?
Are we doing what?
Are we practicing with Anacortes this year?
Or can we?
Anacortes, I do not believe is doing FRC this year.
Okay. So that sounds like it would be a no. Will the wedges break when you try to hang on the bars?
I mean, not planning on it, but disasters can happen.
Is there going to be encoders on the launcher motor? They are Neos, so
Really?
there's encoders built into them. We'll see if we end up using the actual encoders or not. Probably will to judge speeds. Let's see. Don't pneumatics have a tendency to run out if you use them a lot? Say after using them 10 times?
Our pneumatics, we have a compressor which would be constantly building air pressure on the robot.
How does the compressor affect the robot there? Power-wise?
We've used it in the past, and it's not usually been a problem, to my knowledge.
Let's see. Would using the Velcro hamper the release of the ball?
I mean, our plan was to separate the Velcro from the ball when we release it into the hub. So we're not, in our envisioned design, no.
If something breaks on the Swerve Drive during a match, will you be able to fix it / replace parts?
Depends on the part, but for the most part, yes.
It's my understanding that you guys have 2 spare Swerve modules.
Yes. That we could just...
And then what you do is you guys would get replacement parts so that the module that you take out you would repair so that you'd have a module ready to go back in.
That's our plan.
For the mayonnaise robot, how do you plan on keeping the balls from rolling back?
We tested Velcro on tennis balls that we got, and so they weren't going to come off, and in case of that possibility, we had also maybe envisioned putting rollers or some kind of thing to stop them from rolling back on the top of the conveyor belt. So they'd kind of be like locked in place between the conveyor belt and these like top roller things.
Any other questions?
Alright. Thank you guys. So what we're going to do now is we are going to open up the first round of voting. So let's go to the presentation. Alright, so there is a QR code on the screen now. And there's also a link, and if you guys follow that, it will take you to a Google form. And you guys can go ahead, and what you're going to vote on is you're going to vote on one of these 3 robots with no changes. So you're voting on the whole thing, the whole shebang, what they presented. Now, after you do that, don't worry, don't panic. We're still going to let you guys make changes to what you want them to make. But the initial voting is just on what they presented. All right? Okay, so we're going to give you guys a minute or 2 to vote, and then we will tally that up and let you know how things are going. Are you guys nervous?
Yeah.
Just a tad. Just a tiny bit. It's almost like everything we've worked on for a week is on the line.
What are the results? I can't even tell. What's each color?
Okay.
So red is Pogbot, blue is mayonnaise, and yellow is factor.
Ooh,
Dang.
this is interesting. Very, very interesting.
So I'm not sure if we should show the results. I'm going to go back to the...
Let's just give them a minute.
You kind of did just like choke screen
I did.
Yeah, we kind of did just show the screen.
I don't know if we did. I don't know. Maybe they had the camera on us.
Did you? Okay. They had the camera on us.
Oh, good. There you go.
Just had us looking at
yeah.
the polls.
Yeah, that was very interesting. Very, very interesting indeed.
We'll see how the results actually turn out.
I don't even know what your robot looks like, actually. I've seen Error's thing and Isaac's. I've seen ours.
So
I don't know.
Pogbot is the dumper?
Yeah, Pogbot's our dumper.
So it's last year's robot with some modifications.
And Swerve Drive.
So last year's robot with some modifications.
And Swerve Drive.
Swerve Drive.
Do they have a driver that's good enough to do Swerve Drive?
I mean,
we can figure it out.
We need to start training drivers in it like now.
Yeah, we really do. We don't have any drivers.
Just take the drivetrain
I mean,
instead of driving it around.
the way that Swerve Drive works is you just point the joystick in the direction you go, and it should just go in that direction.
All right, so I'm going to check on the voting. So if you guys want to... Yeah, there we go. All right, so...
Oh.
Overwhelming.
Well, it's not completely overwhelming. So we have some votes. All right, so everybody out there, get your votes in. Why don't we do? Should we set a timer? How do we do it?
No, I'd say at 7 o'clock.
At 7. Oh, you want to end it fast?
7 o'clock, yeah.
I feel like this is
7 o'clock.
biased opinion here.
All right, so here's the deal. You know what? No. We're not just gonna go 7 o'clock. Here's the deal. I'm gonna set a timer, and I'm gonna set that timer for 4 minutes, and we're gonna let it go for 4 minutes. So we're going to let it go for 4 minutes. So, let's see. You know, Connor?
Yeah?
You're kind of new.
I am.
So will you tell us about how you found the team and what you're doing here?
Well, so mostly how I found the team was through my friends. A lot of my friends I've known for a while have been coming to robotics for some time and been trying to convince me to come. That was the main reason. Plus, like, I like building things and working with my hands and a lot of stuff. So after a lot of like convincing, I just decided to come, and it's been really fun. I've been enjoying it a lot.
Awesome. So what's the thing that you're looking forward to most this year?
I don't know. It's all really fun. I'm looking forward to, working together with everybody to build a gigantic robot. Knowing what I know from the FTC season, just, putting it all together and seeing it come together as a working robot just sounds so much fun to me.
Alright, so I have a request for you guys. If we do retire the version 2 Swerve Drive, I want you guys to make it into a giant Swerve Drive Lazy Boy chair for me.
Oh my god!
Don't make me look.
Yes.
No,
I feel like we have to send that to Will Poland.
We have to send the giant Lazy Boy Swerve Drive chair to Will Poland?
Yeah.
Just show up at his house.
You know what?
We got a
Here's the
Lazy
deal.
Boy
We'll
for
do
you.
that.
He gave us his address.
We'll do that if Will Poland votes tonight.
Hold on. Isaac, your phone?
Alright, so Will Poland, if you're watching this, if you vote tonight, then when we retire the Swerve Drive, we'll make it into a Lazy Boy chair and we'll ship it to you.
Ship it all the way to Florida.
All the way to Florida. You know what? We'll drive it all the way to Florida.
Yes.
Everyone shows up at his house. Just
We'll drive it in the ambulance.
Lazy Boy.
Yep. What's another? Oh, we'll bring lots of Monster.
Lots of Monster. Alright, so I'm going to check the voting again. So I'm checking the voting again, and ooh, wow, we're doing pretty good.
Yeah.
And
Pretty
you
good.
have 1 minute and 41 seconds left. Ooh, so I was just told to read the comments. Does someone want to check the comments?
Ooh.
For all robots, is there a max speed allowance? What speed do you plan for each robot?
As fast as we can push them, really.
I mean, true.
So I don't think there's a rule about a max speed.
Yeah, not that I'm aware of.
It's just as many motors as you are willing to throw at your drivetrains about how fast you can go.
Yeah, basically you want to be able to go as fast as possible, and the reason why is because if your alliance scores 20 cargo points in total, that would get you a ranking point, so you kind of want to be fast. What's that?
It's Taylor and Mr. Carver just going back and forth.
Oh my god.
Who's Spinner's here?
Any other good questions?
We should probably announce that, or we should probably talk like the people we know.
Tell me about redundancies and reinforcements. How do you plan on supporting the linear slides so that they don't twist? What redundancies do you have in place?
If those linear slides twist, something has gone seriously wrong. Those are made out of 1x2 aluminum blocks, which is pretty strong.
We've had it twist in the past.
Well, it would be...
So, they twisted when we used 80/20 and linear slides.
Well, it also twisted on our robot from last week.
Alright, so we're going to go ahead and cut off the initial voting. And it looks like we have a pretty overwhelming support for Pogbot. So, alright, so we have pretty overwhelming support for Pogbot at 53.8% of the vote. How do you guys feel about that?
I feel pretty good. I don't know about my two companions here.
I feel angry. I came in third.
Alright, so here's the deal. All the robots are doing the same thing, right?
Pretty much.
We are one team. And so basically we're looking at a dumper with a level 2 climb, right?
Yeah.
Okay, so here's what we're going to do now. Now we are going to let you guys vote to make changes to the robot that you voted for, right? So we're going with Pogbot. This year's robot's name is going to be Pogbot.
Yeah.
But we're going to let you guys vote on making changes. So up on the screen is a QR code. And if you guys go ahead and click on that link, it should take you to a survey that offers to make changes to the robot. Alright, so I'm going to open up the changes voting thing so we can see what you're voting for. But we don't want you guys to see that, so they're going to turn the camera on and turn off the slideshow. And I'm going to go ahead and find that one. So let's see, modified voting. There we go.
It's not like we haven't made a launch before.
Okay, so right now we have no responses.
Oh!
We have one response.
Oh, what is it?
Alright, so for the drivetrain, keeping the swerve, and alright, and then there's some ideas about, alright, and then there's people voting on climbing. Alright, so it looks like we're keeping swerve. So you guys are doing swerve. And, ooh, there's some people that are pushing for a launcher.
I had a feeling that... Why'd they just choose this one? I want to know, what about Pogbot did you guys like to just not pick the exact same robot? Was it just the name?
Alright, so we're going to go to the chat, and we're going to see what you guys are saying.
Now I'm kind of curious about what chat's going to say.
Alright, so, it looks like a lot of people are pushing for us adding a launcher, and I'd love if someone wanted to give some reasoning and stuff like that.
And why you didn't just pick the design that already had a launcher?
Well, maybe because they wanted you guys to build Pogbot and then add a launcher.
Ooh! That's something we can do.
So I'm going to go ahead and leave 4 minutes for voting, so you guys can keep voting for the next 4 minutes, and then we'll see where we are.
One person wants to know if they can vote if they're outside of Oak Harbor.
I believe you can. It should be opened up so that anyone can vote, and I think I've seen some people who are not
school district members vote. I think. Probably. Maybe.
No. Oh, okay,
You're
yeah.
saying no to nothing stop.
All right, yeah. So people are voting, and yes, we want everybody who's watching to vote. We want you guys to vote, and let us know what we're doing, and let us know what to do, because we built this robot for the community.
Do you want me to talk about how we can potentially do both a launcher and a dumper?
Well, that's what we did last year.
Yeah, that's literally last year's robot. Last year we took the dumper and put a launcher in the dumper.
Pretty much.
But the community didn't really get to choose on that.
I mean, we also, like, last year we used the exact same robot as the year before, except we added a launcher to it.
But that was in the rules.
Yeah.
So, and also, you know, when we were not in person, it'd be really hard to build a robot. Building the launcher was really hard not in person.
God.
Yeah. Last year was COVID year, and
it was a very interesting year.
Yeah.
It's all been very interesting.
Yeah.
The thing is if we're going to have both a launcher and a dumper, they both have to fit within that 125-pound weight limit.
Yep.
Oh, yeah. Can we get the QR code back up? Some
Oh!
people are asking.
Oh, yeah.
Definitely.
Definitely.
Alright,
We definitely didn't give them enough time.
Alright, sorry about that. There is the QR code. Vote away.
Okay.
Alright, so Aristine, you joined the team last year.
Yeah, I did.
And, okay, so what are your thoughts on FIRST? What are your thoughts on what you're doing, and what are your thoughts on you?
Well, joining the team last year was like a weird year to join because, well, obviously, COVID. I mainly joined because I wanted to get out of my house more, and also because I was kind of returning to the area after a few years. For my ideas on FIRST, it's actually pretty interesting. I like the concept of teaching, like, little kids all the way up to high schoolers, like, all about robotics, and I also like being able to help out my community a lot, so.
Awesome. So you also do Skillsusa, and what are some differences between what you do for Skillsusa and what you're doing with the team?
So Skillsusa, I will admit, is a lot more like professionalized. What I do specifically is I work in the engineering side, basically, where I've done, well, next Friday I'm doing a technical drafting competition, and then when February comes, I'm going to be doing a presentation with two others for our, like, invention that we made. But it's a lot more, you work with small groups, or you kind of work by yourself. It's not really like a big team aspect. And we do community service as like a club, but it still seems a bit disjointed.
Alright. And so, you know, I mean, we're all about exchanging things, and one of the things that we're about is about pushing the community to, like, do more service. And so what is something that you are hoping to bring from Skillsusa to help us incorporate in the team?
I mean, I guess I would like to try to bring, like, that's a very hard question, I will admit. Personally, probably a little bit more of, like, of a, I'm trying to think how this, oh, I know. I kind of want to make meetings run a bit smoother when it comes to robotics, because it's a bit of a chaotic mess sometimes.
It can be a bit of a chaotic mess. Oh, and that, Saved by the Bell, there you go, Saved by the Bell. So we're going to go ahead and we're going to look at the voting, and we are going to go ahead and, alright, so just to look, it looks like, yeah, you're definitely keeping Swerve.
Yes.
I love the fact that someone voted for the Kid Apart Drivetrain.
What do we got here?
Alright, so,
we're keeping the dumper?
So keeping the dumper, and there's a lot of people voting for adding a launcher.
So we might consider doing both.
And then the climbing mechanism is definitely a single stage mid-run climber to level 2, which is what you guys already have.
Yeah.
Alright, so we have one last thing for you guys to vote on. And the last thing that we're going to ask you guys to vote on is to vote on a reach goal. Alright, and so there is a QR code, and there are some reach goals.
Are we going to say what a reach goal is?
So a reach goal, oh yeah, why don't you say what a reach goal is?
So basically a reach goal is, once we build the robot that you ask us to build, a reach goal is like what we're going for next. Like, we already built a robot, so how can we improve it? And the reach goal is that Improvise.
It's a goal that we would
Yeah.
go towards if we had more time.
So if we have more time, if we have more weight, if we have more whatever, it's something that we can add afterwards, right? So we wouldn't get rid of the initial design. We would stick with that. We would get that working, and then if we can, like if we get to the end and we find out, like, oh my gosh, look at it, we have 3 weeks left, and the robot's done. Like A, we do a whole lot of driver practice, and B, we might have a sub team that would start working on a reach goal and work on getting another thing working.
What were some of our options for reach goals?
So I think it was adding a launcher or a 2-level climb, or like a 2-stage climb
for this.
Yeah.
A reach goal could be doing the monkey bars.
That is a reach goal and a half. Let's just say that.
Yeah, that would. I think that would be its own robot. Oh, what if we brought back mini bots?
Mini bots?
And we had so
Parasite
there was
bot?
a year where your robot carried around a little FTC robot, and it put it on a pole.
Just deployed it.
And the FTC robot had to climb up the pole and like flick a switch at the top. And we actually that year we did really well. Like that was the year our robot was named Juno because it gave birth to another robot. And the other robot like clamped onto the pole and drove up to the top. It was great.
Wasn't that the year that someone named their child after that robot?
That was the year that someone who graduated from the team after they graduated and they were grown and an adult and they had a job and like all sorts of other things. They got married and they had a child and they named the child after the robot.
I don't think that's allowed in the rules this year, though.
Well,
No, but what if you guys had a mini robot that climbed up the monkey bars and then hoisted you guys up?
That's a lot of
It's like Mission Impossible.
Alright,
And
so
we can
I'm
use
going
our
to
trademark
I'm going to
lipstick
look
dot.
at the voting to see how it's going.
What if we keep the mini robot tethered to our robot so it's not technically detached?
Oh yeah, no, that would
But
be
would
the
that
point.
count as extension then?
Yeah.
Yeah, we'd extend more than 16 inches.
I think you can extend vertically more than 16 inches.
I think there is a limit to how high you can go. It's
There is, but
it's like 5 feet 4 inches or something.
It's a 5 inch.
Alright, so I am going to set
Okay.
a timer, and we've been talking for a little bit.
Yeah.
So, and this is a reach goal thing, so wait, hold on. Someone sent me a message. Oh, it's just a thumbs up. Okay, so I'm going to check the comments. We're going to check the comments, and we're going to check the comments, and I am going to set a timer for, what's a good number? 3 minutes, because we've been talking for a bit, so that you guys can finish up voting for the reach goal.
Oh, you can make a mini kitty robot that would climb up and
wave at the audience.
Is
Wave
that
at the
from,
audience.
is that
At that point, you can
That's
just like
Kilmer.
launch it into the
Oh,
audience.
okay.
Just, like,
I was like, that might be my brother. That sounds like something my little brother would say.
A lot of
But
our
yeah.
group could drink now.
Fireball shooting editions.
Well, oh, I guess it is for
I need to have
Natalie.
fireballs.
Yeah, I guess
Oh
Natalie
my
can
God.
drink now. Natalie
I'm
is that.
5 seconds.
You know what? We can add a fireball mechanism to the robot. We just can't use it in competition.
Darn it.
Wait, can it actually?
Wait, it could just
I
pour
want it to
shots
be able
of
to
fireball.
light
I
fire.
have
Like,
no,
have a laser
no. Jack. I have a feeling that would get us all like expelled from school.
Probably.
Yeah, we should have a robot
But
that
it's something we can do.
Put like balls of
Oh,
fire
yeah,
on
I
a
can
robot that
see
can
it.
ignite
Sorry.
the balls of fire.
We'll put the QR code back. All right, so there's the QR code. Yeah, that would be bad.
Well, we might also we'd either get kicked out of the competition or get kicked out of.
Yeah. Well,
Or
but-
both.
No,
or
actually,
all of the above.
actually,
I
it
think
would be
that's
all
an
of the
option.
above
All of the
because you
above
can't
and
have
then
liquid.
some.
You can't have liquid on your robot.
Well, then just
No,
use
no,
paper
you-
and a lighter.
You would, yeah, no, you wouldn't use liquid. You'd use.
Well, no, if you were pouring
you
shots
use-
of fireball,
you
you'd
use
liquid.
Pyrodex.
We use a solid flammable.
Yeah, we'd use Pyrodex, which is synthetic gunpowder.
I feel like
Just
there's probably
fire.
a rule against.
I feel like there'd be a problem. Yeah, there's probably a rule against that. There's
Probably
probably a
counts
rule
as an
against
extension of the robot.
fireballs shooting off of your robot.
Still being coded.
Four shots of fire.
All right, so we have. If you're planning on voting, you have 1 minute and 3 seconds.
Yeah.
All right, so should we go back to the comments?
Yeah.
Yes.
Maybe.
I feel like they
See what they're talking about? You
There you go.
pouring fireballs?
We're good.
Alright, so going back to the comments.
Okay.
Oh, I'm sorry, Natalie. That's terrible.
What?
She's COVID.
But Logan, I hear your mom's having a coffee date tomorrow morning, and
Ooh, maybe not
I'm
now.
thinking of finding out where that coffee, not tomorrow, Sunday, and I'm thinking of finding out where that coffee date is, and and crashing the party.
But is that still happening now that Tom has COVID?
I don't know.
That's the sad part.
That's the sad.
Maybe
See,
you
COVID is messing everything up.
Maybe you and Rhonda can just go get coffee a day. Then.
Yeah, but I have to wear this.
Well, you can just
slide a straw.
Yes.
I broke a door and didn't get in trouble today.
Wait, who
did that? Robotics.
Who broke the door?
Oh, I know who broke a door. Yeah, no, that was, I know who broke the door, and we don't need to worry about that.
Yeah, we don't need to talk about this on.
Alright, so, let's see. So we're going to go ahead and look at the reach goals, and it looks like you guys would like us to add a launcher as our reach goal. So if we get everything built and everything running, before we are out of time, and even actually into the competition season, we can have a sub-team that will work on getting a launcher working. Alright, so here is my interpretation. I'm going to bring up the comments, and I want you guys to look and see if anybody says that I'm interpreting this wrong. So for our drive base, we're going to have Swerve Drive. We're going to use basically an intake and a conveyor belt to move the ball up to the dumper. And then we're going to dump balls out. That is the plan. We're going for a stage 2 climb, so the second rung. And we are going to, so I said Swerve Drive.
Yep.
I said the dumper. Stage 2 climb.
Yep.
And then our reach goal is adding a launcher once we got everything else all settled and working. Does everybody out in the audience agree with what I just said? And you guys all agree that that's what you guys heard?
That's what I heard.
Yep.
Okay.
And the reach goal is adding a launcher.
The reach goal is adding a launcher, not a multi-level climb. The reach goal is adding a launcher.
Yeah.
Alright, so, just want to go ahead and...
Dumper kind of does imply pneumatics.
Yes, Natalie, we are going to be using pneumatics. I don't know, dumper just sounds weird to me.
You could name the robot Dumper.
No,
its name is
Pogbot. Alright, you guys, so...
No, we're not going to ever announce what that stands for.
I want to go ahead and say thank you to everybody for coming out and joining us tonight. Thank you guys so much for helping us design this robot. If you are a member of a club or group or organization or a class in Oak Harbor School District, we are challenging you to do service for your community. So check out our team webpage and submit your service proposals and hopefully win prizes, right? And they're good prizes. So we will buy equipment for your group or organization, or we'll throw a pizza party for you. All right. So we're hoping that everybody goes out and does cool things, and we want to thank you guys so much for joining us tonight. You guys, it has been quite a week.
It is.
It's not over yet.
And it's not over yet. We have a competition in the morning. So we will see you guys in 6 weeks when you show you the robots.
Speaking of which, I've got to go do that now.
Alright, so thank you guys very much, and we will talk to you guys later.
Thank you.
All right.